A quadratic function is given. A, express the quadratic function in standard form. B, find its vertex and x and y intercepts. C, sketch its graph. So, first thing I need to do is I need to put it in standard form. And as you remember, the way to do that is to complete the square. So we're going to start by factoring out a -3 out of this term and this term. And then we're going to leave this guy out. If you remember, I need to factor out of the first two terms because I want to complete the square here, which means this one I don't want to pull out a -3. I want to just pull it out to the side just to deal with him later. So then I know that P is going to be my middle term, which is -2, divided by 2. It's half of that, which is -1. So P squared is going to be -1 squared, which is actually 1. So I'm going to add 1. And if you remember, I really didn't add 1. I really subtracted 3. So I need to undo that. So I'm going to add 3 on the outside here. So when I complete the square here, finish it up, I get f of x equals -3 x plus p, which is -1, squared plus 1. So that is in standard form. So I'll just put this up here. Now what we're going to do is we are going to find the vertex. And if you remember the vertex in standard form always looks like ax minus h plus k, where hk is our vertex. So it's pretty much the opposite of this, and then the k here. So the opposite of -1 is 1. That's 1. So my vertex is going to be at 1, 1. Okay, now we're going to find my x-intercept. X-intercepts is going to be where y equals 0. So I can put it in, I can set this y equal to 0 or this y equal to 0. Now if I set this first one equal to 0, what I'm going to do is I'm either going to use the quadratic formula or I can factor. You'll find out that factoring doesn't work, so we'll have to use the quadratic formula. But since we've done a lot of quadratic formula, I'm actually going to set this one equal to 0. I actually think this is easier. So what I need to do is I need to get that squared by itself, so I'm going to subtract 1 to both sides. 3x minus 1 squared. Now, if you notice, this guy is getting multiplied to this guy, so we need to undo this guy, so I need to divide by -3. If I divide by -3, I get 1/3 equals x minus 1 squared. Now I can square root both sides, and when you square root both sides, make sure you remember plus or minus on that side. So I get x minus 1 equals plus or minus the square root of 1/3. Add 1 to both sides, and I get x equals 1 plus or minus the square root of 1 over 3. Now remember, the square root of 1 over 3 is the same thing as the square root of 1 over the square root of 3, which is 1 over the square root of 3, which I need to rationalize because I don't want to square it on the bottom. So you end up getting the square root of 3 over 3. So this right here is actually going to be 1 plus or minus the square root of 3 over 3. Now, that means my x-intercepts are going to be 1 plus the square root of 3 over 3, 0, and then 1 minus the square root of 3 over 3, 0. Now to find my y-intercept. After x-intercept, y-intercept's really easy, because all I need to do is go back up to this original, and I would definitely want to do it in the original, because if I set this equal to 0 and this equal to 0, you find you end up getting 0 plus 0 minus 2, which is -2. So my x-intercept is going to be 0, -2. All right, now to graph it. So I know that my vertex is 1, 1, so that's going to go right here. And usually in a normal parabola, it ends up going over 1, up 1, and over 2, up 4 from my vertex. So we go over 1, up 1 here, and then over 2, up 4. That's because 1 squared is 1 and 2 squared is 4. But that's not what we're going to be doing here. We are going to have a vertical stretch of -3. So instead of going over 1, up 1, I'm going to go over 1, up 1, but I'm going to multiply it by -3, so that's going to be down 3 from the vertex. And then it's going to be over 2, usually up 4, but I'm going to multiply that by -3, so I end up getting down 12. And since I can't see it, I'm just going to draw it from here. So it's going to look something like this. All right, now, if you notice, this is the fun part. I can actually kind of guess what 1 plus the square root of 3 over 3 is going to be. That's going to be somewhere in between 1 and 2, which means if I plug into my calculator, I'm going to get somewhere between 1 and 2. And in fact, I can get a better guess. I would say it's about 1.7. 1 minus the square root of 3 over 3 is going to be somewhere between 0 and 1. So that's just a nice little interesting fact.